thewellnesscouch.com, streaming wellness into your lives. This is Up for a Chat with Cindy O'Meara, Karen Smith, and Kim Morrison.
Here we are, up for a chat about the hottest topics that are important to you, inspiring you to awaken the change within. I'm Karen Smith.
I'm Kim Morrison. And I'm Cindy O'Meara.
And today we've got an amazing guest on the show that I think everybody just needs to stop, take a second, take a breath, and grab your pen and paper, because I think today's show is actually going to be a bit of an eye-opener for all of us who have been interested to know what happens behind the scenes inside the bod. So we've got an amazing woman on the show, Margie Smith from Smart DNA, who's going to be revealing what the DNA is, how it influences us, how we test and measure it, and why we need to in the first place. And I tell you, I have been looking forward to today's show since Cindy mentioned that you were going to come on the show with us, Margie. I've been looking forward to it for about 2 weeks because I think that this is probably going to be one of the most fascinating conversations that we've had. And I'm so excited to have you join us and welcome to Up for a Chat.
Thank you so much for having me today.
It's an absolute treat. Now, Cindy actually found you. Cindy, tell us how did you discover this incredible woman with all of this knowledge?
Well, I had heard of Smart DNA, and I've probably heard of Smart DNA for the last, it might be 12 months. And you and I and Kim also know Cara, who is learning to be a consultant for Smart DNA. And it was Cara.
Yeah, that's right.
Yeah, she was the one who said, Cindy, you need to learn about this. You're going to love it. It's just down your alley. And she sent me Margie's book. And Margie is the author of a book called Gene Genius: Understand Your DNA and Create Your Own Genetic Roadmap to Health and Happiness. So I interviewed Cara and Sue, and as a result, we somehow got Margie. I don't know how, because I know she's a very busy lady. So, Margie, what I would love to ask you is, how did you get into this? What did you wake up one morning at the end of your high school certificate and go, I'm going to do DNA testing?
I always wanted to be a scientist. In fact, I think I was born to be a scientist. The first thing I ever bought with my pocket money was a microscope, and it sort of went on from there. But my interest in genetics really came from my family background. My parents gave birth to my sister Jennifer, who had spina bifida, and it was quite a severe case. So she had a neural tube defect, so the spinal cord didn't close. And then my parents, 18 months later, gave birth to my brother Malcolm, who had a slight neural tube defect. So we're 2 children in the family with this issue. And I remember at the age of 13 declaring to my parents that there must be something wrong with their DNA for this to have happened. I don't think they were very pleased with me, but but I think that really was a pivotal point in my life where I wanted to understand what it was about DNA and how could it be that my parents had given birth to 2 children with the same problem. And so my interest in genetics really stemmed from there. And, the truth is that now we understand what the actual problem is, that if my mum had had enough folate or the right kind of folate in her diet, then we would have overcome the genetic issue that actually had resulted in my 2 siblings having spina bifida. So it's really what shaped my life, my family situation, and then my interest in science, and it really all sort of came together in my late 20s when I had the opportunity to look at early onset Alzheimer's disease. And so I've had a very broad and varied career in pathology, everything from anatomical pathology, the weird things that people can grow in their bodies, right through to the genetic causes for those very rare and heritable types of cancers. And from there, really, once I'd seen all of the basic causes of things that can go wrong with DNA, I started to think about preventative health. And that's where the co-founder, Simone Walsh, came into play. She asked me one day, she said, "What do you know about nutritional genomics? Because I reckon it's going to be a big thing." And I've really been interested in that. And then she said, "Well, maybe we should try and put together a screen for people to use that for preventative health." So that's really how our company came about in 2009, was by putting together what we knew from science about gene-nutrient interactions and what we could do in a preventative health sense. So that's me sort of in a very big nutshell.
Oh, that's amazing that you were doing it at such a young age and thinking about it. And thank goodness that the two of you got your minds together and your intellect together and decided to do this, because just reading and listening and what you've done and your book, I think we need to go here. So let's first talk about what is nutrigenomics. Let's just see what that is first.
Well, I think as you put it, nutrigenomics, so there's two parts. There's sort of a nutrient part and then our genome part, and how nutrients and our genome interact. How do nutrients turn genes on and off, or upregulate or downregulate those genes, and what are the consequences for health? So it's not necessarily saying that you're going to develop any particular disease. What it's saying is that you may not metabolize omega-3 fatty acids as well as another person. So that being the case, then the recommended daily intake for you would need to be altered in comparison to someone who is able to metabolize omega-3 fatty acids really well. So from a preventative health perspective, you start thinking, okay, well, where are omega-3s important? Well, obviously, downregulating inflammation is one. Modern-day psychiatry now recognises that omega-3 fatty acids are very important for brain health, for stress and anxiety. So this type of information is incredibly important if you want to use it in a preventative health sense.
Oh, I think it's wonderful. It's almost precision medicine, isn't it? Or precision nutrition. And at the moment, we are probably in imprecision medicine and nutrition, because we were all told, in the 70s and 80s, everybody should be on the low-fat, high-carbohydrate diet. And we've seen the disaster of that. And then it was, everybody should take folic acid before they get pregnant or during pregnancy. And now I want you to correct me if I'm wrong on this, but now we're seeing midline problems. So we may have stop spina bifida, but now we're seeing midline problems in children such as tongue tie and lip tie. And there seems to be some issue with our ability to turn folic acid into folate and other active forms that may be causing that problem. Would you like to address how precise we actually can start to become? Do you do medications as well as nutrition, or just nutrigenomics?
Well, really, I'm the scientist that has developed the test, and we use practitioners to actually interpret that information, because they can take into account the clinical picture for that individual. So it's really appropriate that a practitioner does that. In terms of, what kind of folate a person may need based on genetics, we have to be careful here and think about how do we actually measure methylation, because that's really what we're talking about here with MTHFR. We've got two major genetic changes, well, one's more important than the other. However, either individually or combined, those two polymorphisms or DNA changes can affect how the enzyme functions. Now here, many people say, look, I'm a compound heterozygote for MTHFR, I have a mutation. The truth is that it's not a mutation as such. It's a polymorphism. It's a DNA change that's naturally occurring in the population. Now, even if you are a compound heterozygote or you have 70% reduced enzyme activity for MTHFR, that doesn't mean that you necessarily have a problem at that particular point in time. And one way to actually measure how well your methylation cycle is working is to look at homocysteine as a marker. So we know that for measuring, so homocysteine, so let's break that down. The whole point of the methylation pathway, and one of the byproducts that this cycling or this pathway produces is a product called homocysteine. Now, we've got an enzyme that breaks that apart because it's quite toxic and you don't want to have a lot of homocysteine circulating in your body. So this particular enzyme is B12 dependent. So now not only are we talking about folate or methylated folate, but we're talking about another B vitamin, B12. Now that enzyme is called MTHFR. It will break apart homocysteine. And one of the very important things about methylation is that it produces cysteines. Now, if you were invited to a birthday party for an enzyme, what you would take it in a big, big box with a nice big ribbon is a box full of cysteines, because enzymes love cysteines, and that's what methylation produces. It produces methionine and these lovely cysteines. So to a greater or lesser extent, we're able to produce cysteine, we're able to reduce nasty homocysteine back to more natural products that can be reused in the cycling. So it's really important for individuals to understand what their homocysteine reading is. If it's between 5 and 8, that's great. That's really good DNA repair. We want our cells to faithfully replicate. If nothing else in our life is faithful to us, we want our DNA to be faithful to us and make exact copies of itself. So when we talk about people having DNA changes, it may not necessarily be a bad thing at that point in time. If, however, let's say you're a compound heterozygote, you have a homocysteine reading of 15 or 16, then that's when you need to start looking at B vitamins, but more importantly, the types of B vitamins that you're actually intaking. So, for example, if you're 70% reduced with your MTHFR enzyme, B2 is very important for you as an individual. It may be that methylated folate is a better product for you than folate, because remember, when MTHFR polymorphisms are in play, they down-regulate how efficient that enzyme can function. So it's a little bit like having a car and not being able to get up through the high gears, that the enzyme works very slowly and it's not able to methylate folate very well. So one of the things that individuals can do is use methylated folate. And basically what you're saying to the MTHFR enzyme is, look, you're not functioning very quickly. I'm actually going to step behind you in the pathway now. I'm going to step right over the top of you and apply a methylated folate to my methylation pathway. Now, the other enzymes that are important here are B12 dependent enzymes such as MTR and MTHFR, and they are involved in reducing homocysteine. And then there are other enzymes that are B6 dependent, such as CBS. So really, we need to put this into a context. Just because you might have a particular DNA polymorphism doesn't mean that you actually have a problem. It may be that your diet is able to stimulate and keep that pathway functioning. But for others, they may have problems with sleep, they may have stress, anxiety, and a number of other health issues. I mean, poor methylation is associated with a number of disease processes, and that's why we need a clinical context to fit all of this into. So hopefully I've answered your question, Cindy, but if I haven't, please.
I would love to ask a question, Margie.
Go.
I was going to say, I hope Kimmy's going to ask these questions, because I'm like, my head is spinning right now.
I want to bring you into the family home and out of the science realm, and I'd love you to explain to me in layperson's terms so many people will say things like, oh, look, I've got that problem because it's in the genes, or I can't help that. My mother was like that, and so was my grandmother. When people say...
What are we talking about? Is it a personality defect or
anything? People will use that often. They'll say it's in my genes. You know, they put on weight easily, or they've got diabetes like their grandmother and great-grandmother, or they've got a breast cancer like their mother, grandmother, and great-grandmother. I don't know. A lot of people will say, oh, it's in my genes, almost as if that's an acceptable, and it's an acceptable medical explanation for their situation. So now that we have a much better understanding around things like epigenetics, and obviously now around understanding, what are you suggesting then that when someone says it's in my genes, how do we support ourselves from, or them, from looking into this deeper and going down the round that you're suggesting?
Well, I wish I had a really cool, simple answer for all of that, because when we talk about genes, I mean, genes have many different functions. So if you're looking at breast cancer, for example, and someone says, oh, that's in my genes, if you're talking about BRCA1 and BRCA2 genes, then, you know, they are very, very important genes because they're tumor suppressor genes. And when they are faulty, you know, that can be really problematic, and there's very high risk of developing breast cancer. When you compare that to diabetes as the other example that you gave, then, you know, there are probably many, many genes at play in terms of that diabetes risk. But that doesn't mean that we can't reduce our risk as individuals when it comes to diabetes, for example. So by understanding you know, what's important in terms of a heart health-based diet for you as an individual is important. I mean, I think this is a public health issue in terms of cardiovascular health, that we recommend a Mediterranean-style diet. But really, based on genetics, that diet needs some tweaks in terms of the percentage of protein, fats, and carbohydrates in that diet. So when you think about diabetes, often there's a cardiovascular component to it. There's often hypertension as well, especially when you're heading more towards metabolic syndrome. So when it comes to the testing that we do, it's very important to understand how you metabolize lipids. It's very important to understand your diabetes risk. In our panel, one of the genes we look at is called FTO, and I affectionately refer to it as the fatso gene. Now, because this gene and this particular DNA, the DNA change that we look at, if you have one, or more importantly, if you have two copies of the more risky genotype, then we know that those individuals left to their own devices will pick foods that are very energy dense, very fat laden, and therefore they have a propensity to not only gain weight but also store body fat. So for these individuals, we need protein with every meal. We know epigenetically that for the FTO gene, that if you exercise, you get better control of leptin. And you're going to say, so what? Well, leptin controls how hungry we feel. So if you exercise and you have this genetic variant, epigenetically, you will turn on genes that give you better control of leptin, and you're less likely to overeat. And importantly, you need to steer clear of foods that are high sugar, high fat content in order to manage your weight. So you need to keep your calories from fats and carbs a lot lower, and pick low GI fruits and vegetables, not processed foods.
So when you do someone's genetic testing through Smart DNA, you then will see, are these the SNPs? Is the FTO a SNP?
Yeah, FTO is a gene with a SNP in it. That's right. Yeah.
So,
and
first of all, what is a SNP? Let's talk about, well, what's a SNP? And my other question was, these DNA polymorphisms that we're having, why are we just having them because of the chemicals or the food that we're consuming, why are all these polymorphisms happening, or have they always happened throughout time?
Okay, so first of all, a SNP is called SNP, called single nucleotide polymorphism. And polymorphism always means occurring in quite a high percentage in the population. So they're kind of normal variants. As to why they are important, when you look at FTO, for example, and you look at how much our diet has changed in the last century or more, it probably wasn't that much of a factor. But when you look at today's nutrition on the backbone of individuals who harbour these SNPs, it's very easy to have an accelerated course into diabetes, for example, because the nutrient inputs now are, the food is more processed. I mean, you have to agree, there's more chemicals in our environment, and people are under a lot of pressure, so we also have stress playing a role in disease states as well. That basically genes and polymorphisms that may not have been important in the past are important now because we've reached a critical point. Our diet is just so disparate from what it was even in my grandmother's time. I mean, you'd agree there are items masquerading as food in supermarkets that really are so far removed from what food should be that we have aisles that our grandparents just wouldn't recognise in supermarkets.
Yeah, I agree entirely with you, and that's what I've been harping on for 30-something years, and hoping people will start to listen. But a large percentage of the population are continuing to consume these foods, and they're probably not really the ones that will be tested by you. I feel that the people that, and I might be wrong here, Margie, so mark me if I'm wrong, I feel the people that may be being tested by you are out there seeking because they've realised that there's something wrong with them and they want to know what they have to do in order to get better, rather than just taking, like a medication. And we know that Crestor, which I think is the 4th biggest seller in the US of medications, 22 people need to take it for one person to benefit. And that's, the whole, that's in the statin drugs, which I'm speaking about for those who are not sure what Crestor is. So they're not changing their diet. So who are the people that are coming to you? Are they the ones that are like us, who are always looking to improve, or are they people who are very sick and really need help?
I think there's a range of people. Certainly young people are looking from a preventative health perspective so that they can stay on a healthy path for themselves. And then we have people who, and Crestor's a great example, those statin drugs for cardiovascular health. There are those individuals who are now feeling the side effects of taking statin drugs. Maybe they haven't been given CoQ10, which is also there to help them in terms of getting some relief from muscle cramping as one of the side effects of taking a statin drug. I think that the public is questioning more and more the use of pharmaceutical drugs, and are they actually going to benefit from them? I mean, I think there's a plethora of evidence out there now to show that these statin drugs really don't improve your longevity at all, may be involved in increased dementia risk, and have a number of other side effects. But, it's human nature too. When you think about it, you're told that you've got heart disease. Do you want to change your diet, or do you want to take the pill? Do you want to take this little tablet? It's human nature to want to take that little tablet in some respects, because the notion of changing your diet, and look, let's be frank about this. Even if we tell a person with cardiovascular disease to follow a Mediterranean style diet, 50% of the time, if you don't use genetics, 50% of the time you'll get that right, just like the toss of a coin, and the other 50% of the time you will not improve that person's cholesterol parameters. You will, in fact, make them worse. And there are some sex-specific differences between men and women around those nutritional inputs. So it's definitely not a one-size-fits-all. And I have had doctors come up and talk to me after I've given a presentation on this, saying that explains why my patient who was overweight, their cholesterol profile wasn't that bad, but I put them on a Mediterranean-style diet, and lo and behold, I made their cholesterol profile worse. I wondered what had gone on. So, so metabolic health is really the key to this. So if you're carrying a few extra kilos, but, your cholesterol profile is really good, you don't have hypertension, you're probably tracking pretty well. So you have to be very careful about what you're going to do. If you're going to see food as medicine, then make sure you use it in the right way for you based on your genetics.
You talked about homocysteine, and that's now that we're talking about, heart disease, it was, first of all, the gold standard was cholesterol, and then it was LDLs and HDLs and ratios, and now I'm hearing more about looking at other parameters in the blood, such as homocysteine, and if homocysteine is high, then your rate of heart disease may be greater. And they were looking at other parameters, but I can't remember the names of them. Do you see that this is where it's going, that we're going to move away from cholesterol being a marker of heart disease and maybe look at homocysteine as one of the markers? Because you see it in blood tests. You see people being tested for homocysteine now.
Okay, so what if I told you we had a test for heart disease, and look, it's a fantastic test, but it's not actually going to measure what's going to kill you. What would you think of that test?
What's the point?
Yeah, what's the point? But that's what we have now. That's actually what we have now.
I love it.
That no one realises it. The thing is, our standard cholesterol profile will not measure what's going to kill you. Okay? It just does not measure small, dense LDLs. And so the LDL that you see on your cholesterol report measures types 1 and 2. They're large, fluffy, buoyant LDLs. The LDLs that are going to kill you are types 3 through to 7, and they're called small, dense LDLs, and they're small, and they can basically attack your blood vessels, your heart, okay, and cause heart disease. And not only that, they're easily oxidized. So environmental toxins and pollutants can oxidize them. Human beings, unfortunately, we breathe oxygen, so we are going to become rusty. Anything that inhales oxygen and is required to survive, then, you will start, having cellular rust, as I like to refer to it. So our cholesterol profile measures total cholesterol. Well, look, total cholesterol, even if it's elevated, actually means nothing. And in the Framingham Heart Study, people over the age of 49 who had high total cholesterol or elevated total cholesterol lived the longest. So, but that's one of the indicators for a statin drug.
You're intelligent. You know this. Why does not the rest of the planet get this? I've heard this before, and I actually talk about it, Margie, but doctors don't get this. The cholesterol is the gold standard, or the LDL is the gold standard, and the fact that they're not even measuring our small dense LDLs, it's so frustrating. It is, and I don't understand why. It feels like scientists why don't our medical doctors know this?
That's the question that I'm sitting here thinking the same thing to myself, Cindy. And why is it that we have to do a podcast in order to be educating educating people, when really these are, from what you're suggesting, Margie, these are, and I'm just going to say it, these are bloody life-threatening issues that are being managed inappropriately and certainly not extensively. Surely there's got to be a way to know more. I mean, if you know it, how come the doctors don't know it?
Well, it's a bit like belief systems, and health can be a bit like religion in a way. There's one health product out there for whatever you want to believe in. And mainstream medicine has a particular belief, and that is that statin drugs are the answer, and that's how they are trained. And that's led by Big Pharma. Now, if that came crashing down, I mean, there'd be billions of dollars lost from pharmaceutical industry. But the other is that some people actually are quite comfortable with that paradigm. And there are other people who are now questioning that, who have perhaps been treated in that way, and they've fallen through the cracks of mainstream medicine. And that's where they start to have another realization or another truth around their heart health.
Can I ask you a question? I'm sorry I come in from this angle, but I'd like to know. Angelina Jolie chose to have a double mastectomy because of the BRCA1 gene that her mother, it took her mother's life. Can I ask you a personal question? Do you think that was a good decision? Was that a great insight for all of us women around the world? Do you think that just created more fear? What did that decision do on a global basis and for women that may have the BRCA1 gene?
Firstly, I'd like to say that, having worked in that area with genetic counsellors and providing the results of that testing and knowing that it was, those results when we detected a mutation in the lab, that would have a significant outcome for the recipient of that information, that I do think it's a very personal decision. Some people will think that you can manage it through natural therapies, and maybe you can. And that's very much, again, a personal choice. But if you actually understand that these genes, these BRCA genes, BRCA1 and BRCA2, when they have a mutation in them, they are no longer able to suppress tumour growth in your body. So it's not just breast cancer, it can be ovarian cancer, pancreatic cancer, and so on. And it affects men and women in those families. So I never make judgments around that because I do think it's a very deeply personal decision in terms of how that's managed and the types of decisions that people want to make. Because it can be quite fraught. If you're a young woman, you haven't yet had children, and you have to contemplate how you're going to manage this disease process and how you're going to reduce your risk. So you could say, well, it's a risk. Unfortunately, the risks are very high with these BRCA mutations. They're 70% and above. Sometimes when you look at a family pedigree, you can make some decisions in terms of, okay, when does it look as if the tumours are becoming activated or detected and causing a problem? Can we manage the individual up to that point? So I don't think there's any real easy answer around that, except to say from my position, I think Angelina Jolie made the right decision for her, and it may have had resonance with other women in the same situation and may have helped in those instances.
I even had a friend of mine was advised to remove her ovaries when she was diagnosed with the gene, with the BRCA2 gene.
Yeah.
So I think... Sorry, carry on, Margie.
I was just going to say, I mean, and having your ovaries removed has a lot of consequences, and it depends on your age and stage in life and other decisions that you need to make. So that's what I was saying then. It's not easy. I think that until you're actually in that situation, if you're ever in that situation, I hope that, I wish we didn't have people in that situation, that you just don't know what you would do.
Yeah, absolutely.
Yeah.
I read something, Margie, and I only just read it, and I don't remember where I read it, but you might be able to confirm or not confirm what I read. But it said that these certain gene mutations, such as the BRCA or celiac gene, or actually had what was it? What did they say? That they were beneficial to some people. So the BRCA gene created more fertility. The celiac gene meant they didn't get as many parasites. So do you think that there was a survival reason for these genes throughout history, or do you think that they're just a gene that is mutated and we just have, and it's just the luck of the draw? What do you think? Do you think that there was a reason for these mutations?
I didn't read that article, but you've touched on a really important point, though, around these diseases and genes. So, we're living, at least twice as long as we're meant to, through medical intervention or interventions that we put in place. So diseases that may not really have caused a problem in the past are, seeming to be expanded now because we are living longer, and breast cancer could be put into that category. Even in my PhD, looking at early onset Alzheimer's disease, it wasn't until individuals started living longer that the disease started to be noticed. So I do know in terms of people being resistant to parasites that there's a particular genetic constellations that individuals can inherit that make them resistant to parasite infections, for example. So
it's interesting, I find, like what we see as something that may have been is not good, may have meant the perpetuation of the species, may have meant that, we were more fertile, or we could resist parasites and therefore give a microbiome to our prodigy that was, or to our, our offsprings that was far better, So I have this fight with myself all the time about these SNPs and these genes, and I would love to know more. I feel like we're just a burgeoning science, and there's so much more for us to learn. Would you say that, Margie? Do you think that there's heaps more to learn for what we're now doing?
Oh, absolutely. And before we went live, I was talking about connection, how everything is connected. So our microbiome, the bacteria in our gut and the metabolites they produce, can basically pull the strings on our innate genome. So there are bacteria there that can upregulate inflammation in our bodies. And if you have markers for inflammation, then the bacteria can be, cranking up inflammation in your body. So really a lot of health disorders, I believe, really stem from your gut microbiome, and that should really be a place of healing in terms of trying to get a better microbiome picture.
On that note, Margie, with the skin microbiome as well, there's a thing like toxicity cellular response and things like that. So chemicals like parabens that are tested, they're considered safe on the skin because they do not break the cell wall of the cells in the body. However, what they don't tell us is that parabens actually can disrupt the DNA of the cell. But because we don't get told that, and it's only based on the structure of the cell, what blows me away is no one talks about the DNA. Do you know much about the DNA reaction with certain chemicals in the environment and what goes on to our body, like how that affects us as well?
Yeah, for sure. I mean, it's not just our skin, but it's any chemicals or toxins that we breathe in. The biggest and sole determinator for how we process environmental toxins such as parabens and hormone disrupting xenoestrogens, or from our environment, basically is our genes. So if you do not have a good genetic profile in terms of being able to eliminate these toxins, then you are extremely vulnerable to these parabens and xenoestrogens or hormone disrupting chemicals. I mean, I find it astounding that we talk about chemicals and then we talk about how safe they are. I mean, it just doesn't seem like they should be in the same sentence.
No, I agree with you. And what I'd love to ask you, though, for people listening to this podcast and me myself, my brain's kind of Oh my gosh, I'm not quite sure. You intellects are incredibly astounding to be around. But what I'd love to know is, okay, I'm a mum, I've got 2 kids, I've got a husband that's been told he's an undermethylator. What can I do in my home to help my family understand that their genes can be a determinant for their ongoing health and wellness? What can I do if I'm not sure? Do I go and get testing for everybody? Do we go into that like what's the stay-at-home mum or the general person at home? What can we do?
Well, I mean, that's a pretty big question. In terms of your husband, or actually mean? Does it mean his MTHFR enzyme is not working as it should be?
I don't know. All I know is that apparently when he had his methylation tested, or however they do it, most people should sit around 10 or something, I was told, and he's in something like 160, which was way above, but not the highest. And what he was told by our beautiful holistic integrative doctor was that food would be a major part of that to help his body. When you
looking at B vitamins, do you mean? Yes. And
yes.
Take a protein and
yes, and zinc was a big thing as well. I'm not sure why or how, but this is the thing. You can be told these things. We may not necessarily understand the science behind it, being a mum or a wife, but we just want to know if there was a general principle to support the health and wellness, or is there not a general principle? Is it all so individual that you can't? We all have to be tested. I mean, if I'm giving my children the most organic food I can, I'm not doing too many carbs maybe, and I'm certainly not doing processed foods. I'm doing the best that I can, but we do know that some foods, even though they're healthy, even though they're organic, are going to create havoc for some people. I mean, for a lot of people listening to this, you can feel so overwhelmed with the information. You're like, oh, there's no point, we're going to die of something. And I'm asking the question of what can we do as a starting point? You know, how do we help, regardless of the methylation, regardless of anything? What can I do? Is there a generalized principle on how we can support our genes and the way that they are expressed?
Okay, so there's a couple of things that you've said there. Let me tell the audience that there's a theory that, you know, your DNA has an agenda, and the agenda is that it wants you to make more copies of itself. So it wants you to reproduce and have children. Now, generally speaking, we do that in our 20s and 30s. And then by the time you get to around the age of 40, your DNA turns around and says to you, well, thanks very much. You've made a few copies of me. I'm really happy. And you're on your own now, so see you later. So suddenly people are in their late 30s and 40s, they've got stress, they suddenly find out they're an undermethylator, and maybe they're not thinking straight, maybe they're not coping with stress.
Maybe they're having a midlife crisis.
Maybe a midlife crisis, yeah, that's right. I mean, you know, buying a gold chain.
Harley Davidson. The planet doesn't need me anymore.
Society. The point I'm trying to make is for the mum and the 2 kids. Look, for the kids, you know, try and focus on that really healthy diet and organic food, and reduce your exposure to environmental toxins and pollutants. And for the husband, who may be around the age of 30 or 40, where suddenly DNA has decided to have a holiday and not help you anymore, that's when you probably need to look to more personalised solutions for that person in terms of their B vitamins. They might need copper and zinc as well, especially if you're thinking pyrols, and that's another whole area associated with methylation. So, you know, and so it goes on. So I think, yeah, and the other thing we need to consider is that, you know, about 50 or 60 years ago, you know, if you got over the age of 60, you're likely to go on and continue and have a very sort of, you know, good later stages of your life. Now in our world today, you know, that's come back to about the age of 40. So if you get over the age of 40 without developing a cancer or some other condition, then you're likely to go on and have a pretty good later stage of life. But, it just goes to show the impact of poor nutrition in our environment. And also work stressors. I mean, stress, human beings are programmed for stress.
Yes.
And some people are more programmed for stress responses than others. So, you look at two individuals in a very stressful working environment, one may seem to flourish whilst the other falters and ends up having stress, anxiety, or gaining a whole lot of weight simply because their cortisol levels have gone through the roof and they just can't manage their stress. And that happens in the workplace. Our genetics are often come into play in terms of how we manage stress. And, we always talk about stress is going to kill us, but it's not actually stress itself. It's all of the physiological responses that human beings have. Remember, we're really ancient. It's taken, a couple of million years for us to evolve to this point. And it's really hardly perfection, is it? I mean, it's, how many supermodels are there in the world? 10. And it's taken 2 million years to get to this state. Well, I don't know. Those averages don't sound very good, do they?
And you're talking to 3 of those 10. So
yeah, that's right. Well, that's what I figured. So,
thanks for that, Kimmy. Made my day.
Yeah, we're talking to the genetic elite here today.
So, Margie, how do these tests get carried out?
Well, we use a saliva sample, and from that saliva contains white cells, and we extract the DNA from those white cells. And from there, we have developed a validated test, and that's really important. If you're going to get a gene test done, you want to know that it's validated. That means that we can replicate the data so reducing error rates. You don't want to be engaging in any test that has high error rates. And basically, we look at segments across the genome that are associated with those gene nutrient responses or stress responses for individuals as well. Because it's important to understand that if you've got gene polymorphisms that are associated with increased responses to stress, you need to know how to manage that. We're very ancient beings. We're not programmed to run 24/7, but some people try to manage their vehicle, the body that they're in that way, and it's just not going to work over the long term. So we look at all those areas because I want a holistic approach. I want individuals to understand their gene-nutrient interactions, their stress responses, and there's also some information there on exercise and whether they are more programmed for endurance or sprint or somewhere in between. So that they can go out, they can exercise, they can de-stress without causing injury to themselves.
You also test the microbiome, I believe, Margie, and you don't culture it, you test the DNA, RNA. Am I correct in saying that?
Yeah, so basically, every bacteria has a fingerprint, and that fingerprint is sort of like a barcode on the bacteria, and we're able to read that barcode on the bacteria and then assign it to whichever group the bacteria belongs to. So we do look at the gut microbiome, and we've had some really interesting findings associated with disease processes, for example, and even IBS. I mean, how common is IBS these days? And just, teasing that apart into its various categories, whether it's diarrhea or constipation or mixed type. So we're able to basically look at the major phylum and then drill down through that phylum. Now, one of the things that Smart DNA has done is build a curated database. So that means that every sequence in there we've handpicked, and we know that it matches. If you get a hit and it matches that barcode, we know that it is exactly that bacteria. There are other commercial databases that can be used, but we found that we were often getting erroneous information that a person might have a bacteria from a rock pool in Korea, which is hardly likely, but so we're getting that sort of information. So that's why we've developed our own curated database. So,
Margie, is there such a thing as having innate intelligence where we can actually feel what feels right to us without knowing the exact DNA coding that we possess? Can we go by how we feel, or is that even clouded these days?
I think for a lot of individuals it's clouded. I do meet practitioners, though, who are very in tune with their bodies, and I think that that's an art that human beings have lost over time, and I think that's why we need these really specialised practitioners to help get us back on track again. Yeah, I do think that sometimes people work out through trial and error what's good for them, but sometimes in that trial and error they can be not very pleasant experiences. So at least looking at your DNA or looking at your gut microbiome or both, you can get a clearer picture and an understanding of where you need to be in terms of your nutritional intake for good overall health.
So how do I go about getting these tests? Do I have to get a doctor's referral? Would it be a good idea just out of interest to get the whole family done? Like what's the next step?
So the next step...
And are they expensive?
Order the tests through your practitioner, and your practitioner will be able to guide you through that process in terms of taking the sample, whether it's saliva sample or...
but do they? Would your general practitioner know this?
No, it's not your general practitioner, no. It's really integrative doctors and nutritionists and naturopaths that use this testing mostly, and that's globally. So they're practitioners that are generally trained in this area.
And how much are the tests, approximately?
So, for Australia, it's $396 for the saliva test, and the gut microbiome is $330.
And would you recommend both, or is one enough?
It depends on what the health issue is. I mean, obviously, if you've got a gut problem, then I'd recommend the microbiome test. But if you're wanting to know for general health, for cardiovascular health, your methylation pathway, and how well you metabolize sodium, for example, or fats and so on, then that would be a really good starting point.
And like we know with the saliva test, I'm going to spit on something. How do you get my gut microbiome? Do I have to or bring something up or poo it out? How does that one work?
So basically, you poop into a little container, and we use a kit called an OmniGut kit. And you basically take some of that fecal material and push it into the top of the tube, and then when you close that lid, miraculously the poop ends up down the tube in a special preservative, and it's got a little ball bearing in there as well. So when you tip the tube backwards and forwards, it breaks up the fecal sample, and then we're able to use it in the lab to process. So we use collection devices, so you don't have to spit on anybody or poop inappropriately.
Now, a question I have for you is, if there are practitioners listening, they probably want to know more. Do you or do anybody do events around the country, around Australia or around the world, where practitioners or lay people can come and listen to this information? Because I have 100 questions for you, Margie, and we are at the end of our hour. So I believe that I have heard of one on the Gold Coast, and I'm going to it. I think it's in May. But is there a place that we can go to find out where these events are that we can go to and listen more?
Well, we've got an online training course for practitioners if they happen to be listening. And in the near future, Smart DNA will be doing more promotional events and more public speaking in this area, so that they can learn more about nutrigenomic testing, microbiome testing, and the future of personalised health, really. I think,
so you actually concentrated on nutrition, but there is, I listened to a cardiologist last year in Australia. He came out from America, and he said that there is actually medical genomics where he can see, like he was a cardiologist, so the protocol is, Plavix, beta blockers, aspirin, statin drugs, and I believe there's blood pressure one that everybody takes. But he says there are some people that can process aspirin and there are other people that can't. So will you get into medical genomics as well in the future?
More in terms of pharmacogenomics and drug responses. That may be something that we look at. I do think that is important. I guess that our philosophy is that, there's a cure to every disease process out there in nature, and we just have to discover that. This notion of you take a plethora of tablets and that's what everybody gets is a complete misnomer, because, as you say, some people will metabolize these pharmacological drugs in very different ways. It's the same with omega-3s, for example. And I gave that as an example before, that just because we take an omega-3 and it's supposed to be really good for us and it's good for our brain health, based on genetics, we know that the conformation of some genes means that omega-3 isn't utilized as well as people with different genotypes. Does that mean that they shouldn't take omega-3s? No, it doesn't mean that. But it means that we need to understand that everything we're eating, whether it's a supplement, whether it's a food, or whether it's a pharmacological drug, that we as individuals will metabolize those things differently. And sure, you might be able to group some people together and make a broader brushstroke. But this notion of just having, half a dozen tablets that you take and that's some panacea for cardiovascular disease, I think, that's patently wrong. Like, you can't treat one person as part of a herd and expect that everyone's going to have the same results. And medicine doesn't have time to start teasing apart all of this right now. They just want this one approach, and that's why people fall through the cracks.
Yeah. So we've talked about nutrition, we've talked about medications, and you talked about how we process things differently. What about vaccines? Do we process vaccines differently too?
Yeah, we do. And there's been some studies. You can go to PubMed, which is sort of like the Bible for research in the medical arena. And I was looking at some publications the other day from a group where they have shown that children who have adverse events when it comes to vaccination have some very rare genotypes. And it's those in concert that they think contribute to vaccination response, to poor outcomes.
Is that why some children can be seen with vaccine injuries and some can't? Is this what's happening? You know how there's such a debate around vaccination and the principles of vaccination, and yet it is very obvious to some mums that the vaccines have caused the injury. Is that because of our genes?
Well, in the publication that I'm referring to, they were able to demonstrate that it was a number of genes or acting in concert that made it a more risky proposition for these children to have vaccination, that they were able to show that these genes are most likely contributing to the poorer outcome that was observed. But a lot more work needs to be done in this area, and it needs to be proven quite clearly that is the case. So then what do? Do we genotype these children if we have a fingerprint where there's likely to be an adverse outcome? And then how do we actually manage these children? There's a pharmaceutical company then going to produce a vaccine that's modified in some way for these kiddies. And, you have to say that might be a long way off, because it's much easier and it's more cost effective just to produce one vaccination exactly the same way for everybody. It's the same with drugs.
Yeah.
And you know, Margie, if you had the ability to wave a magic wand, what, with your knowledge, what would your wish be for the future of our society based on what you know around the genes? Is it something that you'd really love to see everybody, it's standardized, that we all have gene testing from the moment we're born? Or what's your magic wand feeling?
My magic wand feeling is really not about do we test children from birth and so on. My magic wand feeling would be that everybody on the planet could just get real, have one common truth, not be swayed by money from government or big pharma or anywhere else, and actually just unite and start working out what's really important for human beings on the planet, and try and get to a fundamental truth around health.
Oh, we just fell in love with you. We've got a girl crush.
Hashtag. Hey, one quick question. Law and Order, SVU, crime scenes, you know, does that side of the DNA interest you, and how on earth do they test, you know, is it the same way?
Well, my addiction genes love those shows.
Oh, same. And every time
I am
about
addicted.
the DNA.
Yeah. I cannot watch enough of them. I have to record them.
Yes.
And then when I get a little bit of downtime, I'm there watching those shows. So, yes, my addiction runs very deep through those shows, for sure.
Good. Oh, well, look, we could keep talking with you, beautiful.
Yeah. I can talk forever with you, Margie.
Is there a website people can go to find out more about you? And can you tell us about your book and where it's available?
Well, my book, Gene Genius, is available from Harlequin, and I believe you can buy it on Amazon and online. And sorry, what was the other question? Sorry.
Do you have a website or any way that
website? So just go to smartdna.com.au and look us up there.
Beautiful.
Wonderful.
And can we take you home?
I'm actually very annoying. I'm a little bit OCD. I like things nice and neat and precise. I'd actually make a really good 1950s housewife, if anyone's interested.
You would, except that you'd want everything so perfect it would be scary.
Who's been talking to you?
Yeah, I know your type. I know it. I see you.
You know, I try and overcome it with a good sense of humour. So, you know, we all have our little quirks and idiosyncrasies. We just have to learn to love it all.
Yeah. Margie, are you married? Just out of question.
No, but I am taken.
Yeah. And is he quite playful and out there and kind of a lot of fun? And
Yes. Yeah, complete opposite to me because I'm so boring.
Yep, balance the nerd in you. We love it. Yep. And that's my type. So I'm very pleased that we are getting along here because, I get your husband and I'm very excited for him. No. Oh, we love you. Look, thank you. Is there anything else, any final message or anything you'd like to leave with our listeners?
Just that I really hope that they enjoyed today. I hope we haven't confused you, and hopefully we've just stirred the pot in terms of passion for your own health and well-being.
Yeah, and I think in summary I'd love to say this, that the whole thing of the one size fits all is even more apparent, and how we can ever think that one medication or one vaccination or one food is going to suit all. I think that was probably one of my biggest take-homes from today, and really honouring our differences and that our genes don't determine our future, that whilst we can have those gene or that genome or that actual fingerprint, it doesn't necessarily determine our fate, and that we have a lot more control than we think. Would that be fair to say?
That will be fair to say. And if you think about one size fits all as an item of clothing, I don't know if you've been around the world and you've tried one size fits all in China and one size fits all in the USA. Let me tell you, one size does not fit all.
well, as being three far amazing supermodels, we can all wear each other's clothes. So we're okay on that one. But we totally appreciate it.
Well, I've got genome envy now.
Well, wait till you see mine. It's coming.
Look, Margie, thank you so much for your time. Yeah. Karen had to leave the call. She had another interview to go and do. So we just, on behalf of the three of us, we'd just love to say, please, listeners, go and look up Margie, smartdna.com.au, read her book, Gene Genius. Please place your feedback on all the W's. thewellnesscouch.com/up for a chat. Don't forget to go to the Facebook page, facebook.com/up for a chat. If you've got any questions, thoughts, or feedback on beautiful Margie or what, don't ask me the technical questions. You'll need to hashtag Cindy O'Meara Guru, and we'll bring in beautiful Margaret Smith on that note as well. I'll just have fun with you all, and please remember, speaking of fun, that we still have a couple of places left for our New Zealand trip at the end of this year in October. 2 weeks hiking with us through Queen Charlotte Sound and the south of New Zealand. And for those of you that want to play even bigger, we've got Africa next year as well, which is actually getting more full than the New Zealand trip. So there's a few spaces left on both. Please go to our Facebook page, awakenthechangewithin.com, and you can get all the information there. So, Cindy, as always, it's such a treat with you. And Margie, again, from the bottom of our bottoms, thank you so much for being a part of our world. We love you dearly. And listeners, we look forward to seeing you on the ride next week. Take care.
This has been a production of TheWellnessCouch.com. Check us out on Facebook and join in the conversation on Facebook.com/TheWellnessCouch. Subscribe to each show on iTunes and check us out on Twitter. The Wellness Couch, streaming wellness into your lives. Whilst the Wellness Couch presenter endeavor to provide accurate and helpful information to their listeners, these podcasts cannot take into account individual circumstances and are not intended to be a substitute for health and medical advice from a qualified health professional. You should always seek the advice of a qualified health professional before acting on any of the information provided by any of the Wellness Couch podcasts.